Okay, in this video we're going to have a look at some of the properties that we associate with carboxylic acids because they do behave as typical acids. And we need to remember that carboxylic acids are a weak acid, and we'll come back to what that means in a moment. And the typical reactions of acids is we can see their effects and indicators. We can look at their reactions with bases, and in particular carbonates, because they will lead to the production of carbon dioxide, and we can test for the carbon dioxide using lime water, and that is the test to show for carbonates, but it's also allowing us to see that that is an acid reacting with it. Okay, so let's have a look at these in a little bit more detail. The first one is they are described as weak acids, and remember, weak acids mean that they partially dissociate. Okay, that means they partially break down. For example, if we take ethanoic acid, which is CH3COOH, then what will happen, and we're going to put a reversible symbol in here to show that this is going to be only partially breaking down. What will happen is it will form an ethanoate ion and a hydrogen ion. I believe that only 1 in 1,000 will separate into this. The rest of them remain undissociated, so therefore they partially ionize. Only some of them do this. Compare this to a strong acid. So a strong acid, if you think back, we looked at HCl, hydrochloric acid. That fully ionizes, so the arrow is in one direction to give us H plus and Cl minus. So strong acids fully dissociate and weak acids partially dissociate. Okay. Second feature is their effects on indicator. So if we put any of these indicators in to a carboxylic acid, then we will get the characteristic acid colours. So litmus will turn red, methyl orange will go red colour, and phenolphthalein will go colourless. Okay, so we can distinguish them by that test. Then we've got some reactions here. I've got ethanoic acid reacting with a metal. So remember, acid and metal makes a salt, and it's going to produce hydrogen over here. So if we've got ethanoic acid, CH3COOH, sodium is Na. Now sodium ethanoate is going, sodium ethanoate is going to be the salt, and that's going to have the formula. I know we call it sodium ethanoate, but you write the formula the other way around. It's going to be that. That's the formula for the salt. And then we said we have hydrogen is being produced, which is H2. Okay. That equation is going to need balancing. So we're going to need 2 lots of that to make that work. 2 lots of that, and then 2 lots of that to balance that equation. Okay, and then the final one here is ethanoic acid with the carbonate. So again, this is a neutralization reaction going on here. So we get a salt and water, but because it's a carbonate, we get carbon dioxide. So the salt is going to be lithium ethanoate plus water plus carbon dioxide. Okay. We know that that is H2O, we know that that is there. Lithium carbonate is that. Ethanoic acid is CH3COOH. Okay, lithium ethanoate is that formula. And we need to balance this. We're going to need 2 lots of that and 2 lots of that to make it balance. And it's worth pointing out in here that the carbon dioxide, we can collect the gas, we put the gas through lime water, and the gas will go cloudy, showing us that that is being produced in that reaction. Okay, and that's also the identification of carbonates as well.